For Chapter 9, Section 3, we're going to talk about graphing some of these quadratic functions again, but we're going to be dealing specifically with some transformations that can happen of quadratic functions. So when we talk about transformations of these quadratic functions, we're talking specifically about how we can change the equation slightly, and what it'll do is move the equation around on your graph. So I'm going to show you some examples of how you might see these transformations happen, so that when you're looking at an equation, before you even go to graph it, you can have an idea of what it's going to look like. Now, before we get started, we need to talk about the parent graph and what the parent graph is. So the parent graph is the simplest form of a graph of any type of function. So there are lots of different ways that we can graph things with, like, linear equations, quadratic equations, cubic equations, and so on. And they all have what's called the parent graph, which would be kind of the very original graph where it started at the very beginning. And it's the most simplest form of the graph that we have. For today, we're going to be using our parent function, which would just be y equals x squared. A transformation is going to change your position of your graph. So it's going to move the graph around, or it's going to make the graph become skinnier, become wider. It's going to stretch it, it's going to compress it, like some of those different key words that we'll talk about later on. What we're going to talk about mainly today is how a translation affects your graph, which is when you're moving a figure up, down, left, or right. So when you're pushing it around on the coordinate plane. Now, your parent graph for the quadratic, like I said, is that y equals x squared. Okay, and these are some key points on the parent graph. So when we start doing our transformations today, all of these points is kind of where we're going to start, and we're going to use those to help us understand the movement of the graph. So the vertex of the parent graph is 0, 0, which would be at the origin. So that's right there. The y-intercept and the x-intercept is also at 0, 0. Some other key things is around that vertex point, you'll have reflected points. So like if you go over 1, you're up 1. If you go over 2, you're up here at 4. And the same points are going to be translated over here on this side of the graph as well. So those are some key points that you can look for when you're grabbing the points to move when you start doing your translations. So a translation moves the parent graph, and I want to talk about this example with you guys first. So we have y equals x squared plus 3. So the plus 3 is what has changed on our graph. So I'm going to show you guys really quick on a website called Desmos, which Desmos is used to help you understand what a graph maybe looks like. So if I were to graph my parent function, that y equals x squared, that's right here in the red, okay? And so we can see, you know, it goes through the origin at 0, 0. We'd have a point at 1, 1, if I zoom in here. So there's a point right here. There's a point at -1, +1, just like I showed you guys on the graph on the previous page. Now, let's say I want to add in this new one. So we're looking at the equation that says y equals x squared. Okay, so notice how that's on the parent function there. But ours says plus 3. So if you look, the blue one that I have now moved. Okay, and if you look, all it did is it took that 0, 0 point and it pushed it up 3 spaces here on my graph. And so did 1, 1. Like if I'm at 1, 1 and I count up 1, 2, 3, right there. -1, 1, if I go up 1, 2, 3, it's right there. So it just pushed my graph up. So when I look at this, back in our notes here, and they're asking me how does it move, I would say that this went up 3. And if I wanted to sketch the graph, you could always start by sketching your parent function. So we have a point at 0, 0, 1, 1, -1, 1. So this is the original. And my new one went up 3. So I'm just going to push all these points up. 1, 2, 3. 1, 2, 3. 1, 2, 3 again. And it's still going to have that U shape, but it's just in a different spot on the graph now. So during class, we're going to have you guys experiment using Desmos. But if you're watching this video, you may not have a chance to access Desmos while you're watching. You could always go and kind of play with the Desmos website on your own if you wanted to kind of see what they would have seen when they did this in class with me. But we're going to just kind of go through these ones together and then kind of go over the summary. And like I said, if you want to take time on your own to explore them more using the Desmos website, you can. So for this one, we have x squared minus 2. So again, the minus 2 is going to affect your graph. This time, because it's negative, that's going to push it down 2. Okay, so I'll show you this one on Desmos just so you can see. So this one, you know, was that plus 3 and it pushed it up 3. I'm just going to add another equation here, and I'm going to say y equals x squared, and this time it's minus 2. So that one's in green now, and if you look, it pushed this graph down 2 spots. And it pushed all those points that I've been talking about down 2 spots. Okay, so the red is the parent, this is the one up here, the blue one is the one that we just did, and this green one is what we're on now. So you can see how if it's positive, it's going to push the graph up. If it's negative, it's going to push the graph down. So if I want to graph this one here, again, your parent function, remember, starts at 0, 0, so I'm pushing that down 2. And then you have those points at 1, 1 and negative 1, 1, and those are going down 2 as well. So this is where that graph would be. So when you're sketching these, I don't need to see all the stuff that we had done in sections 1 and 2. Like, I don't need to see your work to find your axis of symmetry and those kind of points. We're just briefly exploring what we think would be happening with these and just doing a real quick sketch of that graph. So what do you think is happening with this one? This one is going to go up 4 because of that plus 4. So again, I start at 0, 0, and I'm going to go up 1, 2, 3, 4. And then I'm going to have those 2 points on either side of that vertex. That was at 1, 1, negative 1, 1. Those got pushed up 4 as well. So this is where that graph would be. So in summary, when you have a number at the end, it's going to move your graph up or down. And a key thing to remember that if it's positive, so if you're adding a number on, that's going to move your graph up. If it's negative, so if you're subtracting a number, that's going to move it down. Now, that's not the only movement that we'll see happen. So if we look at these next couple, they're written a little bit differently here. This time it doesn't just say x plus 2 or x squared plus 2. You've got parentheses involved, and inside the parentheses is where the movement is happening. So this is different. This is not the same thing as this. Okay? These are not the same. Those are not equal because I'm adding 2 to x first and then squaring it. Where over here I was squaring x and then adding 2. So my movement is going to be a little bit different for this one. When your number is on the inside of the parentheses like this, it's either going to move it to the left or to the right. Now, with moving left or right, you almost have to think backwards. Because when we see plus 2, we think, okay, positive. And so I would have moved right, because right is positive on my number line. However, when you're talking about moving a graph, this actually went left 2. And why does it move opposite directions? Well, if I were to set that x plus 2 quantity equal to 0 and solve for x, I got negative 2. And so negative means that I had to move left on my coordinate plane. So a little bit different thinking there. You'll just have to train your brain that when you see something like that inside of your parentheses, that you're moving it to the left or to the right, and it's opposite of what you normally think. Now, when you go to sketch your graph, you can still start with those original 3 points here, and you're going to move all of them to the left 2. So the vertex moves to the left 2, and those other points on either side of the vertex move to the left too. So if you take a look at this one, which way do you think this one moves? So this one says -3, which would mean that it goes right 3. Again, you have to think opposite direction there. And if we graph, my vertex goes over 1, 2, 3 to the right, and then those other points on either side. So let's summarize this rule. A number inside parentheses moves left or right. Okay, and positive, so if you're adding a number, that means that you are moving to the left. If it's negative, that means that you're moving to the right. So these next two practice examples are going to combine the two movements that we've talked about so far. So what I want you guys to do here is take a minute, and I want you to write down how you think it moves, and then I want you to graph a sketch of where you think it should be on the coordinate plane. And when you're ready to go ahead and see what it should have been, you can keep watching the video. So do this one and do this one, and then come back and watch for solutions for both. So for this first one, it moved left 1 and down 3. Because that +1 is inside parentheses and the -3 is outside of them, so that's why there's two different movements happening here. So if I start at my vertex 0, 0, I went left 1 and down 3. There's my new vertex. Then if I'm at 1, 1, I went left 1, down 3. And if you're noticing that pattern where these 2 points are 1 up and 1 to the left, 1 to the right, that's always going to be the case when you're moving that parent function. Those points are always going to be right there in relation to that vertex. For the second practice problem, you should have said that this one moved right 5 and up 2. So there's your vertex, and there's the 2 points on either side. Okay, there is one more type of movement that we need to talk about. So far we've just been dealing with the translations where you're moving something left, right, up, or down. But we also have something called dilations, which does two things. It can either stretch or it can compress the graph. And so we'll talk about kind of what the difference is between those. But we're still dealing with that parent function, that y equals x squared. But what's changed about these ones is that you're going to see a number sitting in front of the x squared. So it'll say like 2x squared or 1/3 x squared. To understand what the difference is between the dilation movements, like whether it stretches or compressions, is you want to take a look at that letter A. If A is a proper fraction, which means that the top number is smaller than the bottom number, and it's between -1 and 1, it will compress the graph. So for example, if you see something like 1/2, 1/3, 3/5, 2/7, anything like that, those are all proper fractions. Those are going to compress your graph. Compressing means that your graph is going to be pushed down. So it's going to take longer for it to open up and create that quadratic form. The other situation is if your A is greater than 1 or less than -1, it's going to stretch the graph. So for example, you'd have like whole numbers, so like -2, +2, -4, +6. You could even have something like 7.5, -8 1/4, anything like that. Those are all bigger than 1 or they're less than -1, and they're going to stretch your graph, which means they're going to make the graph become very, very tall, very, very skinny. So they're going to kind of do two of those things. So compressing the graph makes the graphs become very short and very wide. Stretching makes the graphs become tall and narrow or skinny. Now, if A is positive, it's going to open up. If A is negative, it's going to open down. It's going to flip that graph upside down and create a reflection. So I want to show you an example here. We've got y equals 2x squared. In order for us to graph these, you're going to graph your vertex point. So you're going to graph that point at 0, 0. And then you're going to move in the A units. So in this case, we're going to move 2. And we're going to move that from your vertex. So you're going to go 1 unit to the right and to the left to plot your points there. So for example, when I see my parent graph here, and I want to graph that y equals 2x point, I'm still going to have my point at 0, 0. But this time when I go over 1, I'm going to go up 2. And -1, I'm going to go up 2 as well because of that 2 in front of the x squared. And so this graph, it's still going to be a quadratic form. It's just going to be a lot skinnier than that parent one was. You can see how it's kind of inside of that parent graph, and that's because it stretched it. So if we take a look at this one here, it's very similar to what I just showed you, but notice that number in the front is a -2. So that is still going to stretch your graph, but it's also going to reflect it. So you're going to have your vertex point at 0, 0, and I'm still going to go 1 to the left and 1 to the right, but instead of going up 2 like I did on that last one, I'm going to go down 2 because it's a -2. So this is that same graph that I just graphed up above, except it's flipped upside down because we have that negative sign. So to finish up here, we're going to kind of combine everything that we've talked about, and we're going to go over how you see these quadratics, these parabolas, and it's known as vertex form, and it looks like this, where you're going to see all those movements. You're going to see it moving left or right, up or down. You're going to see it being stretched or compressed. The H and the K, that's telling you if it's moving left or right, up or down, and that's going to be your new vertex. And when you pull it, you want to make sure when you pull the H, you want to make sure that you pull the opposite sign. Because remember when we talked about that movement left or right, we had to think opposite directions. Your K is going to be whatever it looks like, whether it's positive or negative. And then, like I said, your A is going to be your stretch or your compression, and that's going to also tell you what direction the graph is going to go, whether it's going to open up or if it's going to open down. So I'm going to show you an example here, and then we've got a couple of practice problems for you to try. So for this first one, I have y equals 4x, or 4 times x plus 2 squared minus 1. So I need to pull a couple of things. First thing would be my vertex, so my HK. So remember, 4 is in the A spot, 2 is in the H, that -1 is in the K. When I pull H, I need to pull the opposite sign. So I need to pull -2, and then pull -1 for my K. And A is going to be your 4. So to graph this, I'm going to start at my vertex, so I'm going to go -2, -1, and draw that point. And then I'm still going to go 1 to the left and 1 to the right, but I'm going to go up 4. So this graph is even skinnier than that one that I had shown you up above. So that's really what you need to do here, and if it helps you to, kind of say, like, okay, I went left 2, down 1, and it has a stretch of 4. If that helps you understand like where your point should go, I would go ahead and write that kind of thing out. So there are 2 practice problems for you. There's this one here, and then this one here. And I want you guys to try to do both of those to practice what I just went over with you guys. And if you, like I said, pause the video here. go ahead and then resume when you're ready to see what your movements should have looked like. So for this first one, the vertex, you should have pulled a positive 5 because it's the opposite of what you see up here, and then positive 2. So that means that you're going to move right 5 and up 2. As far as your dilation goes, this is a stretch of negative 3. So it's going to flip that graph upside down because it's negative. So to graph it here, you should have started at 5, 2, which is right there. And then when you go left and right, you should have gone down 1, 2, 3. And for that last practice problem, vertex should be at negative 1, negative 3. So you're going to go left 1, down 3. Your A value is 2, which means it's going to stretch 2 units. So if I go negative 1, down 3, I'm starting here. And then I go over 1 to the left and to the right, and I go up 2 because my A is a positive 2 to get my new graph.